So last class we talked a little bit about inverse trig, definitions, the domains, the ranges, and some of the rationale between why we had to truncate the domain so we can discuss the inverse. So we do a little bit more trig stuff before we actually jump in and look at some of the calculus parts. Let's say we had one. Suppose we're told that y equals arc sine of x. And we would like to find, let's say they specify this, and they want us to find cosine of y. So that little extra part they're telling us there with y between 0 and pi over 2, they're just telling us that so that we know, maybe we could discuss the inverse, so we're not breaking any rules. So guys, if y equals arc sine of x, that would be like saying sine of y equals x, correct? Same thing. If we want to take it a step further, it would be like saying sine of y equals x over 1. We want to go nuts. So for a lot of these, it's going to help if we could draw a reference triangle. So sine of y, it's kind of weird. Our angle here is going to be y. And what's sine equal to in terms of SOHCAHTOA? Sine is what?
Opposite over hypotenuse.
Good. Opposite over hypotenuse. Opposite over hypotenuse. Shoot, how are we going to find the length of this side?
Pythagoras.
Pythagorean theorem is going to work, yeah. So, what do we want to call this? Let's call this q, just for the hell of it. So I know that q squared plus x squared equals 1 squared. So I want to solve for q. So q squared equals 1 minus x squared, so q would be the square root of 1 minus x squared. So this side here has to be the square root of 1 minus x squared. All right. So we want to figure out cosine of y. We've got our happy little reference triangle over there. What would cosine of y be? Good. So adjacent over hypotenuse. So the square root of 1 minus x squared. The hypotenuse is 1, so that's what we would get. So for a lot of these, it's going to help if we could take whatever inverse function they give us, rewrite it in the usual way, draw a right triangle, and figure out what the heck we need, whether it's tangent, cosine, etc. We should be able to get it from that reference triangle. So let me give you guys another like this, see what y'all can do. Giving us arc secant. So rewrite it, take the reciprocals over top. So this would be the same as saying secant of y equals root 5 over 2. I mean, I'm good with SOHCAHTOA, but secant, yeah, I don't know what secant is off the top of my head. So let's write this in terms of cosine. So if secant of y is root 5 over 2, what would cosine of y be? 2 over root 5. That's going to work. That's really all that we need to get started here. I'll say I'll call this y. So cosine we know is adjacent over hypotenuse. So adjacent, hypotenuse, that's a root 5. So what would this side have to be? I mean, 2 squared plus this squared is going to equal root 5 squared. So 2 or 4 plus what equals 5? 1, yes, it's going to have to be 1. 4 plus 1 equals 5. So yeah, if we wanted to call this q, we could set it up similarly. let's say 2 squared plus root 5 squared equals q squared. Another way around is math. 2 squared plus q squared equals root 5 squared. So 4 plus q squared equals 5. Q squared is 1. So q would be 1. So we did the hard part. Now we just got to figure out tangent of y. What's tangent equal to in terms of SOHCAHTOA? Opposite over adjacent? I like it. Here's y. Opposite over adjacent would be 1/2. Cool. So there will be some questions like this as we're going through the homework, just to refresh our memory. Inverse, reciprocals, reference triangles, all that good stuff. So like we see this in Trig for a couple sections, and then that's kind of it. It's just going to pop up again and again. Because I wasn't super confident with this one. Let's just look at one other here. So let's say they wanted us to find secant of arcsine of 4/5. So what we kind of want to do here is we need to unravel this. It's almost like peeling away at an onion. This whole thing here is going to be theta. And basically we're looking for secant of this theta. So if arcsine of 4/5 equals theta, that's the same thing as saying sine of theta equals 4/5. Let's draw that. So sine of theta equals 4/5. Sine is opposite over hypotenuse. So without thinking too hard, what would this have to be for the adjacent?
1.
If it's a right triangle? Say it louder so I can get happy. 3. Yeah, it's a 3, 4, 5 triangle. Good. So what we want to find here is secant of theta. So same deal. Secant we know is the reciprocal of cosine. Cosine we had just seen was adjacent over hypotenuse. So secant's going to have to be hypotenuse over adjacent. Basically, once we get the reference triangle drawn, it's game over. So hypotenuse over adjacent, we would have 5/3 here for an answer. So there will be some, yeah, go ahead.
Oh, so you have to find both? You found the secant and the sine? Is that what you did?
No, so so this part here, first, this part in the inside here, we're saying arcsine of 4/5 is theta, and that's equivalent to saying sine of theta equals 4/5. So we just use this to draw our triangle.
Okay.
And then looking at the bigger picture, we wanted secant of theta, secant of this whole thing. So once we got that drawn, secant's going to be 5/3. Yeah. Other questions, guys? Yeah.
How long will we be using the arc trig?
Through the end of the semester. Yeah. The next one we're going to be looking at is integrals for the next section, and then we're going to get into hyperbolic trig and hyperbolic inverse trig. So yeah, trig stuff is going to be here. The calc part though, it's not going to be like, oh shit, I need to draw a reference triangle and what do I do? It's going to be which formula do I use? So. Some of these you guys might remember in trig. Some of them you could actually punch them into your calculator. Like you could do arcsine of 4/5 and see what we get. It's no big deal. But once they start throwing in stuff like secant or cosecant or cotangent, I mean, we don't have a secant button on our calculator. There's no way to just punch it in and get the answer. We need to know how to manipulate it like this.
Could I get one that does?
I haven't seen one. I mean, you would have to like do a reciprocal and play with it a bit. It's easier just to draw the triangle, honestly. So we got our inverse first trig functions, and we're gonna have 6 derivative formulas. So the first one, if we want the derivative of arc sine, let's say arc sine of u more general, this is gonna be u prime divided by the square root of 1 minus u squared. And I'm gonna do these in pairs. So that's the first one. So does anybody know what the co-function is for sine? What sine's co-function? Cosine. So the derivative of cosine, of arc cosine, is going to be the same thing except with the negative. So we've got negative u prime over the square root of 1 minus u squared. Like sine and cosine are cofunctions, secant and cosecant are cofunctions, tangent and cotangent are cofunctions. So they differ just by the co. Sine, cosine, let's do tangent there. So d dx r tan of u. This is going to be u prime over 1 plus u squared. And the cofunction for tangent, cotangent. This is going to be negative u prime over 1 plus u squared. And then we've got the last ones, secant and cosecant. Of arc secant u. What's a little bit weirder still is negative u prime over absolute value of u times the square root of u squared minus 1. A little bit longer. And then the derivative of arc cosecant of u. I apologize, guys. The secant is positive, cosecant's negative. Yeah. Secant positive up top, cosecant negative u prime over absolute value of u times the square root of u squared minus 4. So the co-functions, cosine, cotangent, cosecant, they all have a negative. The others are positive. And you can see these are all really super similar. We switch the sign around a couple places or shift the u squareds and the 1s. They're all very, very similar. It's real easy to get mixed up with these. So again, these will be given to you for the 4th test. I'll give you guys a formula sheet. They'll be on it. Of derivatives. I believe there's 24 in total at this point. Everything from like the derivative of a constant, product rule, quotient rule, chain rule. So if you want to find the derivative with respect to x of arc sine of 3x. All right, so we got the function y equals arc sine of 3x. They're telling us to take the derivative of it. So guys, what would u be here? 3x. Yeah, you use 3x. So I'm going to go look at my arc sine formula. All right, I need a u. I also need a u prime. So what would u prime be? 3. Just for clarity, I'm going to write down the formula. It's going to be u prime over the square root of 1 minus u squared. And we're going to plug it in, see what we get. So u prime, 3, over the square root of 1 minus 9x squared. Look at it, see is there anything cute that we could do? I mean, we could factor this into the difference of squares in the bottom. That's not going to really do much. We could just leave it like this. That would be acceptable. Nothing's going to really cancel or happen there. Well, that would make sense, guys? Okay. Try this one, see what we come up with. few examples. For right now, this seems easy, awesome. I mean, it will come to an end. We'll start looking at some more fun ones in a bit. Yeah. So yeah, we start gentle. We're nice. Guys, work this one out and see what we come up with. Look at our tan, u prime up top, over 1 plus u squared, so 4x times 4x, 16x squared. Cool. If you want to swap them on the bottom, that's fine too. I'm probably going to leave it just like this because that's what the formula says, just so I can reinforce what the hell the formula is. But if you want to swap them around on the bottom, that's fine too. All right. So we had dx, arc sine of root x. So let's get this started at least. U here is going to be root x. What's u prime, guys? 1 over 2 root x. Good. We've seen him time and time again. That's what it's going to be. Let's plug this in and see what we get. So we're back to arc sine. So up top we've got a u prime. So u prime is 1 over 2 root x. On the bottom, we've got a square root of 1 minus u squared. So what's going to be on the bottom? Square root of x plus 1 minus x. I like that. Again, if I put a root x in there, root x squared is just going to be x. So we've got this. That's a bit clumsy to write like this. So let's think about this. We could think of it as 1 over 2. Then I've got a root x times root 1 minus x. So if we wanted to, we could do square root of x, 1 minus x like this. That would be fine as our final answer. If we don't see that, flip and multiply. 1 over 2 root x, 1 minus x. Since these are both the square root, we could put them underneath the same radical. Take us over here. Good. Again, if we did chosen to distribute here and call it x minus x squared, I mean, that's okay too if we want to do it that way. No big deal. The one thing we do want to be looking out for, we always want to look out to see if there's a perfect square or something that we could take out. So what I mean by that is, let's say, you guys don't have to copy this down. Let's say we work this out and we ended up with 1 over, I don't know, 3 times the square root of 16x minus 1. This here, definitely, if I have a root 16, I would absolutely pull that out. Call this a 1 over 12, x minus 1. I would say 4 times 3 is 12. Over here, there's no perfect squares. I'm going to have an x and a 1 minus x. There's nothing that we can do. There will be some cases later where there is a perfect square that we can pull out. Let's play with one with ease. Say y equals arc secant e to the 2x. And I want you guys to tell me what's y prime equal to. So work on this one, guys. See what we come up with. And guys, it might not be immediately obvious, but if we have an e to the x times itself, we have like an e to the x times an e to the x. Yeah, we could think of that as e to the x squared. Usually that's going to be written as e to the 2x. Because remember, a power to a power we multiply. So I mean, if you see an e to the 2x, you could almost think of that as e to the x times e to the x. Just a reminder.
What if that is squared?
I'm sorry?
What if that is squared? These two squared?
E to the 4x.
Wouldn't it be e to the,
Power to a power we multiply.
would it be e to the 4x squared?
If we got e to the two x times e to the two x. You got two ways we can think about it. Power to a power we multiply and you get 4x. Or if we multiply, we add exponents. 2x plus 2x would be either way 4x. So for this one here, secant, we got u prime up top. So 2 e to the 2x. Over the absolute value of u, so guys,
Cancel.
e to the 2x, I mean, that's always going to be positive. That's not going to be negative. And then we've got the square root of u squared. So if this is u, and if I square it, I'm going to get e to the 4x minus 1. These guys cancel.
That's it.
2 e to the 4x minus 1. Anyhow, this is a difference of squares, but factoring it isn't going to, cancel or do anything good for us. So we could just leave them like that. That would be acceptable. That one make sense, guys? Okay. So let's actually look at some fun ones now. Bless you. So we'll do one fun one just together, step by step, go through the whole process. Some of these, the algebra can be a little bit tricky when we're simplifying it. So let's look at our first real one for the day. So we got y equals arc sine x plus x times the square root of 1 minus x squared. So just like everything else, these new 6 derivative rules, they could be mixed in with product rules, quotient rules, chain rules, implicit derivatives, everything we've seen. It's just more stuff to, make our stew with. So we want to take the derivative here. So the derivative of arc sine of x, well, we could think that u here is like x. So if u is x, what would u prime be?
1.
1. So I get 1 over the square root of 1 minus x squared. Just following the first formula there, that's not too bad. What rule am I going to need, though, for the second term up here? Yeah, we're going to have to use a product rule. This would be u. This would be v. So let's list our u's and our v's over here. U is x. U prime is 1. V is the square root of 1 minus x squared. V prime, well, 1/2 comes down. Let's actually do it bigger here and just tidy it up. So we could say this is the same as 1 minus x squared to the half. So when we go to derive it, the half hops down times what's inside, the 1 less power, times the derivative of what's inside, which would be negative 2x. Down, inside, 1 less, derivative of the inside. So we can see our 2's cancel. So up top, we're going to have a negative x. On the bottom, we're going to have the square root of 1 minus x squared. So we've got a negative x up top. 1 minus x squared to the negative 1/2. Negative means it's in the bottom. 1/2 means it's the square root. So v prime is negative x over the square root of 1 minus x squared. All right. It's not beautiful, but this will hopefully work. We want to put these together. U prime v. And then plus v prime u. So plus and negative is going to be minus. So we're going to have a minus x squared over square root of 1 minus x squared. Now here's the problem, guys. For problems like this, we could simplify this a lot. So should be a couple like alarm bells going off. And hopefully we say, oh shoot, the square root of 1 minus x squared in all these terms. There must be something that we could do. And there is. Let's get an LCD here and combine these. So right now this guy's over 1. So what would I have to multiply the top and bottom by to get an LCD? Yeah, so we can imagine up here, multiply by root 1 minus x squared. Let's see what this does for us. So now we're good, we've got a common denominator along the bottom. So on the bottom now, we just have a square root of 1 minus x squared. Going across the top, well, I got a 1 plus root 1 minus x squared times root 1 minus x squared is just going to become 1 minus x squared. The root would drop off. And we also have a minus x squared up top. So it looks like up top we got a 2 minus 2x squared. We want to pull a 2 out. What's our final answer going to be here? Good. I've got a 1 minus x squared to the first, a 1 minus x squared to the half on the bottom. 1 minus a half would be a half. Just like we had seen a few times before, I mean, if I have x over root x, it's going to be root x. The same deal here, I've got something to the first over that same something that's under a square root. It's just going to be a square root up top then. Yes? Because they, x over 4. Okay, so, yeah, that looks great. We can deal with this, hopefully. Yeah, in our campus, we go by like seniority, so the people that have been here the longest get first dibs. So I'm not particularly senior, so kind of when it gets be my turn.
Does it matter what order we do this in?
I'm sorry?
Does it matter what order we do this in? Like,
No, not
we
really.
do the arc sign first, and then we do the,
No,
oh,
no, just so long as we do both. Yeah.
For the arc sign part, we distribute it.
No. So guys, what's u here for arc sign? X over 4. So let's just make a note. U is x over 4. What would u prime be?
1 over 4.
Good. Okay. So arc sign of u is going to be u prime. So there's an 8 in front. So we take the derivative, the 8 stays. So I got 8 times u prime, which is 1 over 4. And then it's going to be over the square root of 1 minus u squared. So 1 minus x squared over 16. All right, so it looks like we're going to have a 2 on top, but that's where it's coming from at least. What rule do we need for the second term? Be careful. I'm going to say it's not a quotient.
It's product, right?
It's a product rule, yeah.
So just 1/2.
I mean, there's no function on the bottom. We can just think of it as x over 2 as our first function times root 16 minus x squared as our second. So let's set them up here. So u I'm going to think of as negative x over 2. So u prime would be negative a half. V is going to be the square root of 16 minus x squared. Work out v prime for me, guys. See what we get for v prime here. Good. Practice. V prime is going to be negative x over the square root of 16 minus x squared. Cool. All right, let's put them together and see what we get. So u prime v, these two guys times each other. So negative square root of 16 minus x squared over 2. And then these two guys, u and v prime. So if you multiply those times each other, well, I'm going to get plus x squared over 2 square root of 16 minus x squared. Okay. So we got the arc sign, and then we got u prime v, v prime u over here. That's what they work out to be. let's rewrite this a little bit cleaner. So 8 times a quarter, let's call that 2 root 1 minus x squared over 16. Minus root 16 minus x squared over 2 plus x squared over 2 root 16 minus x squared. Just got really excited. This is fluorescent and sparkles. Go ahead, yeah. 16 minus x squared and a half.
And then half in front.
Half comes down. What's
Times
inside?
that derivative
To the
inside.
1 less power times negative 2x for what's inside. So rewriting this, we got a negative 2x up top. I got a 2 on the bottom, and I got a root 16 minus x squared on the bottom, and those 2's we
Oh, I didn't do the negative 1/2. Okay.
Gotcha. Yes.
Oh, why is, you multiply u prime times b, why is that negative?
I mean, there's u prime. It would be nice if we had a 16 minus x squared on the bottom, but we don't. And over here, it looks really ugly. I got a 1 minus x squared over 16. So let me make a little note over here. We'll do a little bit of algebra. Good. You're on the right track. So we're going to look at this guy right here. So I can think of the square root of 1 minus x squared over 16. We could rewrite 1. We could write that as 16 over 16 minus x squared over 16. So you can see on the bottom here, we've got a 1 over 16 in common. We can rewrite it like that. Hey guys, what's the square root of 1 over 16?
1/4.
1/4. We would want to bring that out. In fact, we have to. So 1/4 and then the square root of 16 minus x squared. Shoot, now we're happy again. Now we're happy again. So I can rewrite this as 2 over 1/4 square root of 16 minus x squared. Hey guys, what's 2 divided by a quarter? What's that? 8. Good. Yeah, we'd like flip and multiply. So 2 over a quarter. 2 and a quarter here, and just cancel them out and put an 8 up top. All right, and then we've got a minus 16 over 2 x squared, 2 root 16 minus x squared. All right, looking at our denominators here, can somebody tell me what our LCD is going to be? Good. So our LCD here looks like it's going to be 2 square root of 16 minus x squared. So on the right, we're good. In the middle, what are we missing? Yeah, so we can do the same thing, top and bottom by root 16 minus x squared. Over here, what are we missing? The top and bottom by 2. So let's rewrite this. At this point now, we're good. We've got our common denominator along the bottom. I'm just going to make one big fraction and say 2 square root of 16 minus x squared, and we can start listing the tops. 8 times 2, that's 16. Minus root 16 minus x squared times root 16 minus x squared. That's just going to be minus 16 minus x squared. In parentheses, we'll distribute the negative later to avoid confusion. And over here, we've got a plus x squared. So guys, if we combine terms up top, what are we going to get? 2x squared. Yeah, 16 minus 16 would cancel. Minus a negative x squared is x squared, and x squared plus x squared is 2x squared. 2's would cancel. Our final answer would be x squared over the square root of 16 minus x squared. Yes, this is like our first, it's like welcome to calculus. Go ahead.
We broke it down on the right-hand side. How did we get to the third one when it's 1 over 16? The square root of.
Oh, there's a 16, a 1/16 in common for both of these, so I pulled it out. Yeah. See what I mean?
Oh, gotcha.
Alexis.
Can we take out the 16 with the correction?
Here, if it was 16 by itself, we
Okay.
could, but since this is here, we can't.
Okay.
Yeah, good question. Other questions, guys? So we got x, arctan 2x, minus 1/4 ln 1 plus 4x squared. So guys, for the first term, x arctan 2x, what rule do we need overall? Product. Yes, this is going to be like our product rule for this first term. So u is x, u prime is 1, v is arctan 2x, arctan 2x. So v prime, we're going to go look for arctan. So arctan of u, the derivative is u prime, so 2. What are we going to have on the bottom?
1 plus, oh, 5? Like,
1 plus, what's 2x times 2x? 4x squared. Good. 1 plus 4x squared. Cool. All right. So we got that. That's the calc part, though. Algebra. Hooray. So these two would be arctan 2x plus 2x over 1 plus 4x squared. So we've taken care of the first term. Well, that second term, that's just a ln of u. It's not going to be too bad. So minus quarter stays because we're multiplying. U here is 1 plus 4x squared. So what would u prime be? 8x. And we know the derivative of ln of u is just u prime over u. So negative a quarter stays times u prime over u. All things considered, not too terrible. It's too bad yet. Let's see, these guys would cancel. 8 over 4 is just 2. Guys, what's our answer here? Good, good, good. Darshan sees it right away. Good. So we got arctan 2x plus 2x over 1 plus 4x squared minus 2x over 1 plus 4x squared. That worked out kind of nice. Those guys are going to cancel each other off. So we're just left with arctan of 2x. You have similar aversions to me, you might think this is fun. I realize I might be in a minority here. It's sort of like we're solving a puzzle to an extent. So guys, let's say we had y equals arctan of x over 2 minus 1 over 2 x squared plus 4. So guys, for the first term, what do we need any special rules? Is it a quotient or product for the arctan? No. What about the second term? 1 over 2 x squared plus 4. Do we need any special rules there? No. Work this out, see what we get. Take the derivative, see what we can combine. About 5 minutes or so. Get your hands dirty. see here these 2's would cancel. We would just be left with x over x squared plus 4 squared. All right. So let's put this together. So this and over here plus x over x squared plus 4 squared. Not too terrible. So I'm going to distribute that 2 on the bottom left and see what we get. So if we send this 2 through, we're going to get 2 plus x squared over 2. Would everybody agree? Okay, we'll take another step, just not skipping too much. So 1 over 2 plus x squared over 2 plus x over x squared plus 4 squared. So it would be swell if I had an x squared plus 4 on the bottom left. What would I have to multiply top and bottom by to get that to happen? Good. Multiply top and bottom by 2. So we get 2 over, and I'm just going to write this x squared plus 4, x over x squared plus 4 squared. All right, so let's take this a little bit further. You guys might be okay, actually. I think you might be.
It's a minus.
I'm sorry?
No, it's not minus.
No, because there was a negative here.
Oh, okay.
Yeah, no, there, yeah.
So do we just times the left side by the x squared plus 4?
I like it. So top and bottom here, x squared plus 4. Thank you for keeping me focused, Dylan. So top and bottom by x squared plus 4. Now we've got a common denominator. So on the bottom, x squared plus 4 squared. Up top, we've got a 2x squared plus x plus 8. We can think about this for a few minutes, see if there's a top factor. Is there anything cute that's going to happen? There isn't. That would just be our answer.
Can you show us how we got the derivative for the, on the right-hand side? You did it earlier and you erased it. So
Oh, yeah, sure.